right, today we're tackling something that is absolutely critical if you're building machine learning models, resampling methods. Think of this as the ultimate reality check, making sure the model you've built isn't just fooling you. So picture this. You've just built a new model, and the accuracy on your training data? An incredible 99%. Sounds amazing, right? But hold on a second. We have to ask ourselves that crucial question. Is this model just too good to be true? You know, this leads us to that classic problem in machine learning called overfitting. And the perfect way to picture this is with an analogy. Imagine your model is a student who has literally memorized every single question and answer on a practice test. That's your training data. They get a perfect score. But then, when they get to the final exam with all new questions they've never seen before, they completely bomb. That's because the model didn't learn the actual concepts, it just memorized the noise. And this right here? This visualizes the problem perfectly. As you keep making a model more and more complex, the error on its training data, that's the blue line, it's almost always going to go down. I mean, of course it will. But look at what happens to the test error, that yellow curve. It goes down for a little while, hits this perfect sweet spot, and then it starts to climb right back up. That, my friends, is overfitting in action. Our whole goal is to find that perfect spot right at the bottom of that U. So how in the world do we find that sweet spot without having some giant separate test set that we can only use once at the very end? Well, the answer is a really clever set of techniques called resampling. It's kind of like giving our model a whole series of smarter practice exams. The core idea here is actually pretty simple. Resampling methods work by taking the data you already have and just, well, reusing it in really smart ways. By splitting it, shuffling it, and retraining on different parts of it, we get to simulate how our model will actually perform on brand new data. This gives us a much more honest and reliable estimate of its performance. All right, let's bring in our first big player. This is cross-validation, or CV for short. I want you to think of cross-validation as your model's tough but fair performance reviewer. Its job is to cut through the noise and give you a straight, honest answer on how well your model is actually going to do out there in the wild. Now, this slide breaks down the most common method, which is called K-fold cross-validation, and it's a really powerful idea. So, step one, you take your data and you split it into, say, K equal groups. We call these folds. Step two, you hold just one of those folds out. That's going to be your temporary test set. Step three, you go and train your model on all the other folds combined. Then in step four, you test your shiny new model on that fold you held out and you write down the error score. But you're not done. Step five, you repeat this whole process, but this time you use a different fold as the test set. You do this until every single fold has had a turn being the test set. And finally, step six, you just average all those error scores together to get one single, super robust and reliable performance metric. So you're probably wondering, okay, but what numbers should I pick for K? And that's a great question. While you can pick different numbers, a huge amount of research and just, real-world practice has shown that setting K to 10 is a fantastic choice. It just hits that sweet spot, giving you a great balance between a reliable estimate and not taking forever to run. It really is the go-to choice for a reason. So to just boil it all down, what's cross-validation's main job? Well, it's got three big ones. First, getting that honest estimate of your test error. Second, it's amazing for tuning your model settings, or parameters, to find the absolute best version. And third, it's perfect for comparing completely different models, head-to-head, to see which one is the true champion. Okay, time to meet our second hero. If cross-validation is the performance reviewer, then the Bootstrap is the risk analyst. See, its job isn't just to tell you how well your model did, but to tell you how certain you can be about that result. It's all about measuring confidence. To really get the bootstrapping, I want you to picture something. Imagine your entire dataset is just a big bag of marbles. That's it. Each marble in that bag is one of your data points. Okay, so the process starts like this. You reach into the bag and you just randomly pull out one single marble. You've just selected your first data point for a new dataset. Now here's the magic. This is the most important part of the bootstrap, so listen close. You look at the marble, you write down what it is, and then you put a copy of it back into the bag. The original is still in your hand, but a copy goes back in. This is called sampling with replacement, and it is the absolute key to the whole thing. It means that the same data point can actually be picked more than once. And you just keep doing that. You draw a marble, you record it, you put a copy back in. You do this over and over again until you've built a brand new data set that's the exact same size as your original one. That's your first Bootstrap sample. And the cool thing is, you can repeat this thousands of times to see just how much your results change from one sample to the next. So what's the point of all that drawing and replacing? Well, the crucial takeaway here is that the Bootstrap is all about quantifying uncertainty. By creating all of these slightly different simulated data sets, we can measure how much a specific result, like, say, a coefficient in our model, bounces around. This gives us something called a standard error, which is a direct measure of our confidence in that number. Okay, so now we've got two really powerful tools, the performance reviewer and the risk analyst, cross-validation and the Bootstrap. So, which one do you use and when? Let's put them side by side. And this, right here, is the money slide. It lays out the fundamental difference perfectly. You use cross-validation when you want to answer the question, how well is my model going to perform on new data? It is all about prediction error. You use the Bootstrap when you want to answer the question, how confident are we in this specific result? It's all about the variability and the uncertainty of a measurement. Two different questions, two different tools. Now, before we wrap this up, let's go over a few common mistakes people make. First, you got to watch out for data leakage. That's when information from your test set accidentally sneaks in and influences your training process. It's a huge no-no. Second, just be aware of the computation time. Some of these methods can be pretty slow, especially on really big data sets. And finally, and this is the big one, use the right tool for the job. Remember, CV is for prediction error, Bootstrap is for uncertainty. Don't mix them up. So what's the bottom line here? Resampling methods like cross-validation and the Bootstrap, they aren't just a nice to have. They are an absolutely essential step for any serious modeling project. They give you the honest, reliable performance estimates you absolutely need before you can even think about sending your model out into the real world. And this leaves us with one final, really important question. Thanks to these methods, you now have an honest score for your model. You know it's not just tricking you on the training data. But is that score actually any good? Is it high enough for what you need to do? And if not, how do we make it better? Well, that's a great topic for our next explainer.